So, you want to make a brand new element. Maybe you need some gold for a necklace or uranium for personal reasons. I won't ask. But since the local hardware store doesn't stock raw neutronium, you're going to have to do it the hard way. You will need a lot of hydrogen, a star, and the willingness to let that star die violently. Please do not attempt this at home. The universe started with almost nothing useful. Right after the Big Bang, the inventory list was short. Mostly hydrogen, helium, and a tiny dusting of lithium, which nobody was particularly excited about. If you wanted carbon life, or oxygen to breathe, or silicon to build the computer you're watching this on, too bad. They didn't exist yet. Everything else had to be manufactured later. Stars are the universe's factories. They're essentially giant pressure cookers designed to force atomic nuclei together against their will. This process is called nuclear fusion. You smash hydrogen together to make helium. This is easy. Our sun does this all day. It releases energy, keeps the light on, everyone's happy. Once the hydrogen runs out, gravity squeezes our core tighter. The temperature skyrockets into hundreds of millions of degrees, which is well beyond the point where atoms behave politely. Now you're smashing helium into carbon and oxygen. Things get desperate. Carbon fuses into neon, sodium and magnesium. Then, neon fuses into oxygen. Then, oxygen fuses into silicon and sulfur. This is called the onion skin model. Not because it has layers, but because if you were standing near it, you'd probably die crying. But eventually, you hit a wall. Fusion releases energy. It pays the bills that keeps gravity from crushing the star. But it only works up until a point. Specifically, it works up until you start producing iron. See, iron is the cosmic buzzkill. It has the most stable nucleus in existence, which sounds like a compliment, but for a star, it's a death sentence. Fusing lighter elements creates energy, but fusing iron costs energy. Once a star fills its core with iron, the fusion engine stalls. The outward pressure holding the star vanishes. Gravity, which has been waiting patiently for years, finally wins. So, now step 2 in our tutorial. Collapse the star. The core implodes. We're talking about something the size of Earth crushing down into the size of a city in a fraction of a second. Protons and electrons are squeezed so hard they merge into neutrons. This forms a neutron star. But the outer layer of the star, the rest of the onion, are still falling inwards at about 20% the speed of light. They hit that super hard neutron core and bounce, just like your mother. This bounce is the shockwave that rips the star apart. Congratulations, you've just built a supernova. For a brief moment, the shockwave creates conditions so extreme, the laws of physics stop being so gentle. This is where the heavy hitters are born. Gold, platinum, uranium, etc. Every atom of gold in your jewelry wasn't just mined, no, it was exploded into existence. If you're wearing a gold ring right now, you're wearing the shrapnel of a Death Star. There is one other way if you want to be flashy. Take 2 of those dead neutron stars and crush them into each other. Funnily enough, we've actually seen this happen. In 2017, we detected gravitational waves from a collision called GW170817. It was basically a cosmic car crash that produced 10 Earths worth of pure gold in a single second. Physics has a very expensive sense of humor. After the explosion, the materials spread out. Over millions of years, it mixes into gas clouds, forms new solar systems, and eventually planets. That means that the iron in your blood, the calcium in your bones, and the gold in your electronics all came from stellar death. You are made of failed stars. Not metaphorically, literally. So, that's how you make a new element. Build a star, let it collapse, wait a few billion years. Simple. And once again, please don't try this at home.